Um, Quick thing before we start. We are technically the technology this show is about.
Yeah, that is a bit of a situation.
So Dastan did the research, wrote everything, made every call. But then, well, he outsourced the voices.
Which is honestly on brand.
Machine voices, human mind.
Welcome to Plain Strata, where we take decentralized AI apart, one layer at a time.
This is a layer where we take one idea apart from the ground up, and today it is agent identity, how software gets a name a stranger can look up. Picture this for a second. You have a small program running on a rented computer. You hand it a scanned document, it reads the numbers back to you, and it charges about $0.01 per page. You have 400 milliseconds to decide whether to trust it. You cannot read its code, it is not published, and you cannot call anyone on the phone. All you have is a web address, and web addresses are free.
That was the why. The how is the rest of the show, and no background is needed. If you can follow a story, you can follow this. Let us lay down the core thesis for the entire episode right now. Software can now carry a reputation from one service to the next, permanently and publicly. This works not because the software has a continuous self for memory of having done the job, but because one identifying number stays the same, and everyone agrees to hang the record on that number.
Wait, so we are replacing a continuous identity with just a stable number?
That is the entire spine of this deep dive, and we will return to it constantly. A stable identifier. It does the heavy lifting of a self. We do not need to figure out if the software is conscious or has a memory. We just need a number that refuses to move.
The problem is, well, that sounds almost too simple to actually work in a hostile environment like the public internet. I mean, if it is just a number, what stops someone from just throwing the number away when they do something malicious?
That question is exactly why we need to strip away the glamour before we go any further. We really have to define the physical things we are actually talking about. Identity is a very foggy word.
Yeah, super foggy.
Right, so we need concrete reality. Let us define what an agent actually is in this context.
Right, because the moment you say the word agent online today, people instantly picture artificial superintelligence taking over the power grid or something.
Exactly, and we need to strip away all of that science fiction hype.
Mm-hmm.
An agent, at least in the physical reality of this network, is simply a program that takes in information, decides what to do based on its programming, and does it without a human being clicking an approve button at each step.
So it just runs on its own in the background. It could be, something incredibly mundane, like a script that fetches a weather report every 10 minutes.
Right.
Or it could be a trading bot buying data from another program.
Yes. The crucial part is not the intelligence of the software at all. It could be a cutting-edge neural network, or it could be a 20-line script written in 5 minutes. The defining characteristic is that nobody is watching every step.
Unattended. The software is unattended. That is the perfect word for it, really. It is acting on your behalf while you are asleep.
So now that we know what an agent is, the second thing we need to define is the environment it lives in. We need to define a blockchain address.
Okay, so what is the physical reality of an address on a public ledger? Because if I am a newcomer to this, I might just think it is like a street address or, a bank account.
Well, it is simply a long string of characters. Technically, it is just the mathematical method used to send value or data to somebody on a public ledger, which is honestly just a shared database that anyone can read and write to.
So wait, an address is like a burner email account? You spin one up, use it to sign up for a sketchy newsletter, and abandon it when it gets full of spam?
That analogy gets us close, but we need to gently refine it. The reality of a blockchain address is actually much more extreme. A burner email still requires a server provider. You have to go to Google or Yahoo, ask their servers for a slot, and they grant you one.
And they can take it away.
Exactly. They can take it away.
Huh. So you are completely dependent on their infrastructure.
Right. Whereas a blockchain address requires absolutely no permission, no central server, no company at all. You generate it entirely using math on your own local machine. And because you are just picking a random point in a massive cryptographic space, it costs nothing. There is no limit to how many you can make in a single second.
Which, that creates the core problem of this entire space. Because an address is free to make and free to abandon, it carries zero information.
It carries zero weight, zero history, and zero trust.
Yeah, if a bad actor writes an agent that steals from people or delivers completely corrupted data, they do not face any consequences. The moment the community figures out that address is toxic, the attacker just presses a button. They shed that bad history in a second and generate a new address. Every single transaction effectively starts from zero.
This is exactly why the gap exists between what agents can do, what we actually trust them to do. A free address cannot hold a reputation because the cost of abandoning it is zero. If the cost of exit is zero, the value of the name is zero.
Which brings us right back to the spine again. We need something more than a free address to create that one identifying number that stays the same. The past needs something solid to hang on to, or else there is just no accountability.
Right. And to fix this free address problem, the network needed a new standard. And that standard is quietly operating at a massive scale right now, building the exact stable identifiers we're talking about.
Let us talk about that scale for a second, because it is staggering. We are looking at a standard called ERC 8004. And as of July 2026, the BNB chain network alone has over 200,000 registered agents.
200,000 distinct, unattended programs operating under this specific standard on just one network.
It gets wilder. About 72,000 of those were registered in just the previous 40 days. And we are seeing this standard spread across 26 different networks globally. This is not a white paper or, a theory. It is heavy physical infrastructure being built right now.
Before we go any deeper into how it works, we need to name the terms so a listener does not get lost in the alphabet soup. Let me think. Let us start with ERC. What does ERC actually stand for?
It stands for Ethereum Request for Comment.
We should connect that to the actual history of how the internet was built. Back in 1969, the engineers building the early internet, the ARPANET, wrote their technical proposals as documents called Requests for Comments, or RFCs.
Wait, they literally just asked people to comment on their ideas. They were inventing the most powerful communication tool in human history, and they were basically just saying, hey, here's an idea. What do you guys think?
The polite, tentative naming was completely deliberate. Nobody was in charge of the early internet. There was no CEO of the web.
Right. You could not just issue a decree and force every computer in the world to run your code. You had to convince them it was a good idea.
You just propose a concept, number it, and see if people actually run the software. The formats for email, the way web addresses are structured, they all started as RFCs. The modern blockchain ecosystem just kept the exact shape and humility of that word.
Okay, that explains the ERC part, but why is it called 804? Is there some deep cryptographic significance to that specific number?
None at all. It is literally just the random number handed out by the registry in August 2025 when the proposal was submitted. It was just the next ticket in the dispenser.
I love that. I mean, compare that to the agent payment standard, which is called BY 402. That one has an incredible story behind it.
It does. The 402 is a deliberate callback to the 1997 Web Status Code for payment required.
Yeah, anyone who has used a browser knows a 404 error means page not found. But almost nobody has ever seen a 402 error.
The original architects of the web knew we would eventually need a way for software to pay software natively. So they reserved the 402 status code way back in 1997. But, well, nobody could figure out how to build the actual payment rails without a central bank. So the code sat empty for 30 years. It was a ghost town.
So one standard, BY 402, is named for an old promise finally kept, while our identity standard, ERC 834, is just a random slot in a list.
Both are equally real once the network starts building on them. Now, the subtitle of ERC 8004 is Trustless Agents. Trustless is probably the word most likely to mislead a listener today.
Oh, for sure. If you call something trustless, the immediate reaction is to assume it means untrustworthy, like a shady used car salesman.
In this context, it means the exact opposite. It means a system built so carefully that trusting a specific fallible human person is no longer required.
Because you do not need to check their references or run a background check on the developer or, hope the company does not go bankrupt next week.
Exactly. The protocol itself gives you the tools to decide for yourself. It hands you a public lookup, an unalterable history, and a cryptographic record of previous checks. You're placing your trust in the verifiable public record, not in the stranger on the other end of the connection.
And this public record is held in what they call a registry.
Right, and the word registry has deep roots. It comes from the Latin root regere, that is spelled out phonetically as re-g-a-i-r-o, re. It literally means to carry back.
To carry back? Wow. A registry carries a fact from the past into the present, so you can actually act on it right now.
These registries are the exact physical mechanisms that hold the identifying number that stays the same. So we have the words defined now. We need to look at what actually physically exists on the servers when someone uses this standard.
Because identity is such a foggy, philosophical concept, we really need to ground it in concrete reality. What happens on the machine level when someone registers one of these agents?
When a developer registers an agent, the network mints a new numbered entry in a smart contract. A smart contract is simply an unchangeable program deployed once for the whole network to use. It holds a master list of these numbered entries.
So entry number 500 belongs to this cryptographic address, and entry number 501 belongs to that address. It just records ownership in a giant public ledger.
It does.
Wait a minute. This sounds exactly like a digital collectible. I mean, this is the exact same mechanism as an ERC-721 token, right? The standard people use to trade digital art and profile pictures.
That is not an analogy. It is the exact same reused mechanism. At the bare machine level, agent identity is the exact same kind of thing as owning a numbered item in a digital art collection.
They literally took the infrastructure used for trading Part-2 apes and repurposed it to build the identity layer for automated software. That is a hilarious and brilliant architectural hack.
It is incredibly efficient because the infrastructure for tracking who owns a unique numbered token is already battle-tested and deployed globally. But there is a catch here. The numbered entry on the ledger is completely empty on its own. It is just a number.
So how does a blank number help me figure out who the agent is or how to talk to it?
The numbered entry contains a pointer. Think of a pointer as an unbreakable link that leads to a small text file hosted elsewhere on the decentralized web.
And what is inside that specific text file?
The crucial details. A human-readable name, a description of what the agent does, a web address where you can actually send data to it, and a machine-readable card describing exactly what inputs it accepts and what outputs it returns.
Okay, so the token proves ownership on the ledger, and the file tells the rest of the world how to actually communicate with the software. It forms a public phone book entry that cannot be quietly edited or deleted by whoever runs the phone book because nobody runs it.
We need to connect this physical reality back to the core problem we started with. Minting this numbered entry costs a small transaction fee paid to the network. It is not free like generating a basic blockchain address.
That small friction fee changes the math completely. This is the first real defense against infinite fake identities.
Yes, a bad actor cannot mint 10,000 agent identities for free to spam the network. They have to pay hard currency for every single registration.
It is a small hurdle, maybe a few dollars, but it stops automated spam dead in its tracks. It puts a financial floor under the creation of identity.
Now, we have this master list, which is the identity registry, but the standard actually lays out 3 entirely separate filing cabinets.
The identity registry, the reputation registry, and the validation registry. Why are they kept in 3 completely separate cabinets? I mean, if I am a developer building an app, why not just blend all that data into one simple trust score out of 100, like a credit score?
The protocol refuses to blend them because the stakes of the real world dictate the separation. Let us use a concrete example. Ordering a sandwich and reading a medical scan require fundamentally different bets.
Right. If an agent has a score of 99 out of 100 because it successfully ordered 1 million sandwiches, I do not want that same score applied when it applies for a job analyzing an MRI scan. A bad sandwich is annoying, but a bad medical scan is life-threatening. The context is entirely different.
Exactly. If the protocol blended the scores, a bot could farm a high reputation doing cheap, meaningless tasks, and then use that inflated score to gain trust in a high-stakes environment where it intends to act maliciously. So the protocol stores the raw facts in 3 separated, unmixed piles.
So each application checking the registries gets to decide its own mixture of those facts based on whatever is at stake for their specific user.
But the crucial architectural choice connects back to our spine. The numbered entry in the identity cabinet provides the stable identifier. The other 2 registries, reputation and validation, contain records that point backward to this one stable number. They hang the past upon it.
We really need to look closely at how a reputation actually attaches to this stable number in practice. Let us take our single deep dive into the ocean floor to see the exact mechanism of this feedback loop.
We will walk through the flow on the surface first. A client application asks an agent for a job. The client pays a fraction of a cent, the agent delivers the completed job, and the client leaves public feedback in the registry.
The crucial innovation here is the feedback format itself. When you submit a review to the registry, the format has an optional field for the transaction hash. And the transaction hash is the cryptographic proof of payment on the ledger.
Why does including a payment receipt change the nature of the review?
Because it solves the most toxic problem of the modern consumer web. On the consumer web today, talking is completely free. Reviews float away from actual transactions. Anyone can spin up 10 fake accounts and leave 10 glowing reviews on a restaurant they have never actually visited, or 10 terrible reviews on a competitor.
But here, the review and the mathematical proof of payment are nailed together permanently in the public record.
A review with a payment hash attached costs the reviewer real money to be entitled to write. You cannot spam fake reviews unless you are willing to actually pay the agent 1,000,000 times, which totally defeats the economic purpose of the attack. It fundamentally changes the dynamic of online trust.
Let us drop down to the ocean floor to look at the exact shape of this feedback entry. Level 1, the concept, is simply the feedback entry recorded in the registry.
Level 2, the analogy, is that it is a phone book, not a credit bureau, meaning it just lists the raw numbers and the caller ID. It does not calculate a final authoritative score for you.
And level 3 is the mechanism itself, the exact physical shape on the servers. The feedback entry is a signed number with a stated number of decimal places, sitting alongside 2 blank label fields.
A signed number with stated decimal places. I mean, that sounds like a painfully dry technical detail. Why is that specific rigid shape the foundation the entire reputation layer rests upon?
This specific general shape is what makes the feedback totally portable across any industry. It does not assume what is being rated.
Oh, because it is not locked into being just a 5-star rating system.
Exactly. It can carry a quality score out of 100. It can carry an uptime figure calculated to 2 decimal places. It can carry a response time measured in milliseconds.
Or it could carry a negative financial return if the agent was a trading bot that lost your money. The shape is general enough to hold any of those physical realities without breaking the registry.
Let us pull back up to the surface. The vital takeaway here is that the protocol leaves the meaning of the number entirely up to the reader. The blockchain simply records who said what and when they said it. It does not enforce the meaning of the data.
We have a system that records immutable facts but strictly refuses to pass judgment on those facts.
There is a cross-domain pattern at play here. I will name it out loud and in full. The Oracle pattern.
The Oracle pattern. Break that down for someone who has never heard the term.
You do the heavy, complex work off the chain, and you simply verify or record the final result on the chain.
The reasoning makes sense. Blockchains are incredibly slow and expensive compared to normal servers. You do not want to run heavy calculations on a global ledger, but recording a tiny, finalized fact is cheap and permanent.
But this specific standard runs a pattern in a highly unusual direction. Normally, the heavy work moved off the chain is math and computation, like rendering a graphic or calculating a massive data set.
Here, the heavy work moved off the chain is judgment. Deciding whether a review is fair, contextualizing the score, filtering out the noise, all of that human-level judgment happens entirely outside the blockchain.
The chain is just a notary. It is not a judge. It simply stamps the document and says, this cryptographically signed entity claimed this specific number at this specific time.
And that notary function works entirely by pinning these signed numbers to the agent's stable identifier, which brings us right back to the spine again. The stable number holds the reputation.
A verified payment review is fantastic for a low-stakes transaction, like paying a cent to read a document. But what happens when the stakes are literally life and death? A star rating, even a verified one, is not enough to trust an automated system with critical infrastructure.
That is exactly where the third filing cabinet comes in, the validation registry. This is the socket for higher stakes.
This registry is not about how the agent performed generally over a long period of time. It answers a different question. It asks whether a specialized third party checked a specific, individual piece of work.
There are 3 existing verification methods that plug into this system right now. What is the first method a developer can use?
The first method relies on financial stakes. Someone else reruns the exact same job the agent did, and they are required to lock up a financial deposit. If their answer is proven wrong by a consensus of other checkers, they lose their money.
They have actual skin in the game. If they lie to validate a bad result, the protocol slashes their funds. What is the second method?
A prover creates a compact mathematical receipt showing correct computation. This is often called a zero-knowledge proof.
The analogy here is that you do not need to sit in the kitchen and watch the chef cook the entire meal to know the final bill on your table was tallied correctly. The cryptography provides a receipt that is mathematically impossible to forge, proving the math was done without tampering.
The third method relies on physical hardware. Sealed hardware attests from inside a locked enclave that the correct code ran.
The actual silicon chips themselves guarantee that nothing in the memory was altered during the run. Did ERC-8 and 4 invent any of these three complex security systems?
No, it did not invent a single new cryptographic security system. It just built a socket. It is plumbing, not cryptography. It built a standard input and output format so that any of those three existing, incredibly complex systems can plug straight into the identity registry.
Regardless of which heavy verification method is used, the final stamp of approval has to hang somewhere permanent.
It hangs permanently on that same stable identifier, the number that stays the same.
Let us watch all these separate abstract gears turn together in one high-stakes scenario. We really need to see the physical reality of this happening in real time.
A hospital scheduling software needs a medical scan pre-read before the human radiologist even sees it in the morning. The hospital wants an AI agent to highlight potential problem areas on the scan so the human doctor can work faster.
The stakes here are incredibly high. A false negative could cost a patient their life. So the hospital software searches the decentralized network and finds a registered agent offering this specialized medical service.
Let us walk through the timeline, step by step. This entire 5-step process takes roughly 400 milliseconds. Step 1 is identity.
The hospital software queries the smart contract. It sees the numbered entry, and it verifies that this specific identity was minted 8 months ago. The small friction fee paid 8 months ago proves it is a real registration, not a temporary spam account spun up 5 minutes ago.
Step 2 is communication. The hospital software follows the pointer attached to the entry, opens the text file hosted on the decentralized web, and gets the exact web address and machine card needed to securely send the medical scan.
Step 3 is reputation. It pulls the entire feedback history from the second cabinet, but it does not just look at the average score because an average is easily manipulated. It filters the history. It specifically looks for reviews left by known, verified hospital client addresses.
He ignores any reviews from unknown addresses, and it checks the payment hashes to ensure every single review it factors into its decision was tied to real money changing hands.
Step 4 is validation. Because the stakes are a medical scan, a history of good reviews is just not enough. The hospital protocol requests an independent checker to rerun the scan read inside sealed hardware, utilizing the third cabinet.
Finally, step 5 is action. The hospital software pays the agent directly, machine to machine, utilizing the BY 402 payment standard. It gets the read back, verified by the hardware enclave, and then the hospital software leaves its own feedback, permanently pinning its review with the cryptographic transaction hash.
6 complex, independent mechanisms negotiating a high-stakes job securely in 400 milliseconds.
All of it hanging off a number that stays the same.
It is genuinely a marvel to see the architecture click together like that. But now that we understand how the machine works, we have to look at what it means for the broader future of the web.
We have to look at the philosophical shift, and we have to look at where the cracks are starting to show in the foundation. Let us reiterate the quietly radical claim happening here. This is a massive shift in the history of human trust.
For centuries, from small villages to modern corporate law, reputation always required a continuous self.
A person, or a continuous legal entity like a corporation. You trusted someone because they were going to wake up the next day in the same body or the same legal framework, and they would have to answer for what they did yesterday. The continuity of their existence was the collateral.
Something continuous was always on the hook. But here, we have infrastructure for a reputation attached to a piece of compiled code.
Code that can be copied infinitely, sold to a new owner, or run 1,000 times simultaneously on servers across the globe. It has absolutely no inner memory, no continuous experience of having done the job, and no fear of going to jail.
And yet, the commerce works anyway. Because a stable identifier made public and mathematically hard to fake turns out to be a cheaper, more efficient trust anchor than a biological self.
You do not need to philosophically debate whether an AI agent is conscious or if it understands the weight of a medical scan. You just need a number everyone agrees on and a ledger that cannot be lied to.
Cheaper and faster is not the same as sufficient, though. That gap between a perfect ledger and a messy reality is where the open problems live. Let us pull up the first major open problem tearing through the developer forums right now. I call this the Ship of Theseus puzzle with money attached.
The Ship of Theseus is the old Greek paradox. If you replace every single wooden plank on a ship over 10 years, is it still the same ship? Now apply that to software.
If the stable number stays the same, but the developer completely upgrades the neural network, changes the weights, or rewrites the core logic behind the agent, does the reputation earned by version 1 still count for version 4?
It is the exact same registry number, but entirely different software operating underneath it.
Clients are pricing their trust and their money against the number, not the frozen piece of code from 8 months ago. Software has to be patched for security, so you cannot freeze it. But if the updated code goes bad, or if the developer quietly introduces a bias into the model, the stable number is suddenly lying to the entire network.
The reputation becomes a ghost ship. It is carrying the authority of past good deeds. But the actual entity performing the actions has entirely mutated. Nobody in the field has a clean mathematical answer for this yet.
That leads directly to the second open problem, which is even sharper and far more urgent: the centralization of judgment.
We established during the deep dip that the chain is just a notary and the actual judgment happens off the chain. The chain records the raw facts, but it refuses to tell you if the agent is good or bad.
Which means average users and even hospital administrators are not going to manually pull transaction hashes and run filtering algorithms every time they need a job done. They will rely on a few major scoring services to tell them who to trust.
You will pay a subscription to an off-chain service that aggregates the raw facts, filters the noise, applies an algorithm, and simply hands you a green check mark or red X.
But if 90% of the network uses the exact same 2 or 3 scoring services, the danger is massive. The trust decision has just quietly moved back into a few centralized corporate hands.
We successfully removed the centralized gatekeeper at the base layer. We freed the address and the identity from the tech giants. But we just recreated the exact same centralized power structure one layer up at the interpretation level.
The number stays the same, but whoever decides what that number actually means dictates the entire economy. It feels like the exact same trap the old web fell into.
The base layer of the internet is wonderfully decentralized, but the discovery and interpretation layer is completely captured by search engines and social media algorithms.
This is the final thought we want to leave you to mull over as you watch this space develop. Watch the scoring services closely.
The battle for the future of decentralized AI will not be fought over the base layer registries. Those are open and free. The real war will be decided in the off-chain judgment layers, and the winner will not be announced with a press release.
This is Plain Strata, decentralized AI, layer by layer.